Yeah, so we would find the mass of individual elements located on the periodic table. Like, for example, carbon. We would find on the periodic table would have a mass of 12.01. And once upon a time, we said AMU, atomic mass unit. Potassium, we could get even more specific. First column on the periodic table. That is not how you spell table. And potassium's atomic mass is 39.10 atomic mass units. And we can get specific for iodine. That's on the 17th column of the periodic table. And this is a big boy. It's 126.90 atomic mass units. The other thing that we said once upon a time, long time ago, was the mass on the periodic table was equal to a mole of that particular substance. Does that sound vaguely familiar? Hopefully. So, the molar mass of a compound is the mass of 1 mole of that compound. Just like the molar mass of an element, so for example, iodine would be 126.90 grams of iodine is equal to 1 mole of iodine. So the molar mass is equal to 1 mole of that very specific compound. That is the elements that make up that compound. The molar mass is simply calculated by adding up the average atomic masses of every element in the compound. And we have taken into consideration that there might be multiples of the same element. Another way to put it would be the molar mass is the sum of all of the elements masses in a compound. This is so complicated that just about everybody can do it. Pardon? Because it's not that complicated. There's very little things going on here that you have to keep track of. So let's do one. Here we have something called, or asking you to calculate the molar mass of C6H12O6, which is a very simple sugar. But hopefully you can identify that you have 6 of these carbon guys, 12 of these hydrogen girls, and 6 of these oxygen units. Okay? So what we're going to do to calculate the molar mass here is we are going to take 6 carbons times the mass of 1 carbon, which is 12.01 grams of carbon on the periodic table. And 6 times 12.01 is 72.06 grams of carbon in this compound, or in the molar mass of this compound. We're going to take the 12 hydrogens times the mass of 1 hydrogen on our periodic table. And 12 times 1.01 is 12.12 grams of hydrogen in this particular compound so far. And then we're going to take our oxygens, right? 6 oxygens times 16 grams of oxygen on the periodic table, which is 96 grams of oxygen. And now we're going to do the hardest part of this whole thing. We're going to add them together. So 96 plus 12.12 plus 72.06 gives us a whopping 180.18 grams of C6H12O6, which would be equal to 1 mole of C6H12O6. All right. Now, here's the thing. How do we write it? Okay. You could write this as 180.18 grams of C6H12O6 over 1 mole of C6H12O6. That's one way you are going to be writing it this unit. Or you could write it as 180.18 grams per mole of C6H12O6. G/mol is the unit of molar mass. Okay, so that's the unit of molar mass. So you need to be able to do this. Like I said, really hard stuff so far. But in case you haven't noticed, everything that we do in chemistry, we always make a little bit harder, right? We try to anyway. So looking at our next one here. How many magnesiums are present? One. Yeah. How many oxygens are present? So this 2 distributes itself to the O, so there's 2 oxygens. How many hydrogens are present? Also 2. Okay? So when you have a 2 outside of the parentheses, it multiplies everything inside the parentheses by that value. Since you all think you're pretty good at this, you want to race? Ready? Set. Calculate the molar mass. Go. Show your work. I know some of you beat me. You had 1 magnesium times its mass, 2 oxygens times its mass, 2 hydrogens times its mass, and then you should add it up to get like 58.33 grams per mole ish. Not too bad, is it? Hopefully. Yes, no? All right. The next thing we're going to talk about is percent composition. I'm going to start talking about percent composition. That's a pizza. Okay. I had to draw a picture because this morning they couldn't figure it out. There was a debate about the right shape pizza. Clearly, there is no correct shape. All shapes are the right shape of pizza. Rectangle, circle. This one is, but like the correct shape of pizza could be rectangle.
I've never seen a rectangle pizza.
That's Milwaukee style.
What? How?
Yeah. If you look up a pizza, it's going to be a circle.
But the point that I'm trying to make though is that it doesn't matter what the shape is all pizza is the correct shape of pizza.
You know, pizza came in a rectangle, I'd be like, whoa, that's odd.
Yeah, it's Rocky Rococo.
How have you not seen Rocky?
Rocky Rococo's is a great example of that.
Yes, and it's good.
That pizza is awesome. I know, it doesn't matter.
Oh my gosh. Anyway, if you were going to calculate the percent of slices of pizza that you're going to eat, I would probably say 100%, but not everybody does that. So when you calculate the percent of anything, it's usually part of that anything divided by the whole of that anything times 100. So if you eat 6 slices out of 8 slices, or the whole pizza, 6 slices out of the whole, times 100, 6 divided by 8 times 100 is you ate 75% of the pizza. And in my head, if you're going to eat 75% of the pizza, you might as well finish it. Because 2 slices left over isn't even a snack. It's like a tease. Just enough to get a taste, but not enough to feel satiated. What?
Is cold pizza good in your
100%.
Yeah.
Cold pizza's so good.
Cold pizza, wait for it, with ranch.
No, not ranch.
One time I ordered a Domino's pizza, put it in the fridge. Just like,
You all can leave.
No, it's no, not with ranch. So
You are wrong.
it's nasty.
You are wrong.
It's just so disgusting. Oh, whoa. Okay, I've
Yeah,
never
okay.
heard of that combination.
have you ever gone
Now-
to Popeyes and gotten little pizza slices you can dip in ranch?
Yeah.
Like, the ranch sauce?
Yeah. All right. Now, percent composition, though, is mass of an element divided by molar mass. Molar mass of the compound. Times 100. So it's part mass of the element divided by the whole molar mass of the compound. Part divided by the whole. Now, so looking at our next example here, there is 1 aluminum, 3 oxygens, 3 hydrogens. When calculating a substance's percent composition, first step, calculate the molar mass. So I have 1 aluminum times the mass of aluminum, which is 26.98. I have 3 oxygens times the mass of oxygen, which is 16, which I believe is, my head is broken today, 48. That's what I thought. That's what I was going to say. 48 grams of oxygen times the mass of hydrogen, because I've got 3 of them, at 1.01 grams. Now, when I go to add this situation up, I get 78.01 grams per mole of Al OH3. Step 2. Calculate the percent comp. Of each element. So for aluminum, the percent of aluminum is going to be equal to 26.98 grams of aluminum over 78.01 grams per mole of AlOH3. Oop. There we go. It's going to be times 100. So 26.98 divided by 78.01. I'm going to get a value here somewhere around 34.59% aluminum. Now, for these problems, we're going to round to 2 decimal places. Round the percent count to 2 decimal places. So we'll do the same thing for oxygen and hydrogen, right? So percent of oxygen would be 48, not 480, 48 grams of oxygen over 78.01 grams per mole of AlOH3. Whole thing times 100. 48 divided by 78.01 gets you something like 61.53%. Lastly, hydrogen. So it's going to be 3.03 grams of hydrogen over 78.01 grams per mole of AlOH3. Times 100. And you get something like 3.88% hydrogen. Look at that. Super complicated. Want to race? Race for pink slips, you know what I'm talking about? Huh? There's 2 sodiums, 1 sulfur, 4 oxygens. Ready, set, calculate. Mm-hmm. There you have it. That is how you calculate the percent composition of stuff. Hope you found that valuable.